Okay. Okay, sorry I'm a little late. A little late. You know, best laid plans and all. You know what they say. You know what they say. Let's see. All right. I tried. Part of the reason I'm late because of 2 reasons. One, I can firmly blame Apple. The other is I tried to actually get Twitch alerts to work. I tried is what I can say. Success was not in the cards for me, but the attempt was made. All right, so who's ready to keep digging deeper into consensus? I, for one, am. I'll give just a little bit of time. I think I unadopted. Yeah, adoption failed. I think I unadopted my Switch somehow. Which means I gotta go press this button again. Like, I don't know. I don't know what I've done. Let's see. Let's do this. Let's do this. Adopting a Switch. Be right back. That's right. I'll be right back. I'm gonna go adopt a Switch. Not like Nintendo Switch, like Switch. I need like a pointy thing. Why do they make these buttons so hard to... I know. There we go. I have. It should be in adoption mode. It should be in adoption mode. Maybe I need to join it with the app. Where's my phone? 1 second. My phone was supposed to be charging. Do I have a plug here for it? Let's see. Where's my adopt things? There we go. Adopt things, and I need a power supply. I need a power. Ooh, will this work? I might be in luck. There we go. Uh-oh, we might have a problem. Where was my little piece of wire? I set that down. Mistakes have been made. Mistakes have been made. Maybe it was fine. Maybe it's fine. It says getting ready. It says it's getting ready. Is it? Let's see. Should show up on port 7 here. Should. Oh, is it actually? Cool. Wait, no, this one. Cool. Okay. Dirk, Nighthound, how are you guys? How are you all doing? I'm sorry, I just, I was trying to get my Twitch alerts to work again. And I broke my network, so I just needed to fix it. All right, we're back up. Twitch alerts are still broken. Twitch alerts are still broken. I think what it had to do was that, or what it has to do is that my Twitch alerts machines want to mount to a specific network, and that network doesn't exist anymore with their static IPs, and so that's the problem. And I need to like just spend some time. So the null cloud machines are powered up now. They're just not working. So anyways, we can get on to, I fixed the switch at least. The switch is now, adopted. How are you doing, Dirk? It's been a while. I wish that Twitch would actually let me know how many people were watching. I know this sounds like stuck up of me, but it would be really cool if I actually knew if people were watching or not. It'd be like super awesome, but that's okay. Still says there's nobody watching. Okay, so today we were talking about consensus. Yesterday we talked about it. We kind of set up a project to start implementing Raft, and we're going to continue doing that today. Now, I actually got invited over to somebody's house, so I'm not going to spend quite as much time because I'm going to take my kids to go. I was going to say touch grass with some other kids, but it's probably too cold to touch grass, so they'll probably do some other stuff. So we're going to do that. So I'm not going to go for like the 4 or 5 hours that I had planned. We'll probably go for 4 hours instead of like 5 or 6. But so yesterday I kind of talked about why consensus was important in distributed applications. Pretty good. Wrote a mission controller today. Oh, really? You wrote a Kubernetes mission controller, Nighthound? That's pretty awesome. What was it for? What does it do? What does it do? Mutating the number of replicas in a deployment. So you make a deployment with like a certain number of replicas and it just screws it up. It just makes a random number. That's fantastic. That's devious. That is devious. Dirk, I hope that your holidays, your Christmas have been going well. I know you said you were busy. I hope that that's a good busy, like doing family stuff and sleeping. I hope it's a good busy. Keep saying this is offline, which is really weird. The 24 porter that I have, because it's not offline. It's actually working. These things are connected via it. And then it's saying adoption failed. That's why I reset it. I'll take care of this afterwards. I don't know. This is a weird problem that happened. The only thing that I did was limit VLAN support through it. So I went in here and I turned PoE off because I didn't need PoE. And then I also updated its VLAN, but I updated it back. So I put it just to the null cloud VLAN to segregate it. But I reset that. And it's still doing it. But that was the only thing I changed. But I'll figure this out after stream. I'm not a Unify Pro. And it's actually not offline. But that's okay. It's okay. We'll talk about more about that. Sorta not really. I'm sorry, Dirk. That's rough. I hope the next 2 weeks go a little bit more smoothly. You know, get some family time in, get some resting in. It can be rough. I know, like, depending on what industry you're in software, it can be pretty rough because, you know, if you support things that are more heavily used when people aren't at work, it can mean that, like, you know, you're getting your most, you know, I used to work at a company that supported industrial kitchens. So like your kitchens in restaurants. And so like the worst day of the year by far is Valentine's Day. Valentine's Day is by far the worst day ever. So like none of us could ever do anything on Valentine's Day because like the amount of traffic we would get during Valentine's Day, not even joking, 20 times the peak of any other peak throughout the year. But I mean, that was true with any holiday as well, you know, during Christmas or any, you know, even like something like Memorial Day, we would peak. And it would be like a big push for everybody. And like we'd also be like trying to get features and stuff out for these things to support them for like the customers and stuff. And so it made holidays, actually, because of the industry that I was in, it made holidays a lot more difficult, because yeah. Holidays were when people used our service the most. All right. Well, let's talk about consensus. Let's talk about the types of consensus, because I think there's a little confusion here. And so that's what I wanted to do. Yes. One second. Let me look at your name. I'm not going to get this right. I'm going to pretend the H is silent, and I'm going to call you Amit and Singh. Amit Singh. Amit Singh. That's what I'm going to call you. Hopefully it's close. We're doing distributed algorithms. Yes. So what we're doing is I'm going over like a little half hour of maybe 20 minutes. It depends on how much conversation you guys want to have about it, about a topic on consensus algorithms. And then I'm spending the next couple hours working on implementing Raft. Yesterday, we got a thing set up. We got some communication set up. We got a development environment set up to do a distributed system. And, we're going to try to implement the Raft protocol over the next 5 days. So yeah. After that, next year, we'll probably do some other distributed ones. I know that we've talked a decent amount about Swim as a clustering protocol. So maybe we'll do a little class on clustering and maybe implement one of those. And we'll do some other ones. Actually, what is it? Is it Fly? Yeah. I think next year we're going to do these. They have what, 5 or 6? 6. They have 5 or 6 distributed algorithms on their Maelstrom platform. And I think that we're going to try to do each of these. Hey, Amit Singh, that's what we're going to do here. So if you like to go over that, we're going to be doing that. And yeah, we're probably going to do these next year. These aren't terribly hard, like the Echo all the way up to like Kafka style logs. We're kind of jumping ahead and doing this. Like we're kind of getting to the to this part, but yeah, we're gonna do some more of those. Today, though, we're specifically talking about consensus. And yesterday we talked a little bit about why consensus among distributed machines is important. And today I wanted to start us with just talking about a bunch of the different types of consensus, because I think too often you say consensus and now people think of blockchain. And a blockchain does use consensus, and we're going to talk about the types of consensus they use, but there are lots of different types of consensus. And so I just wanted to help people start to categorize them a little bit. Then we're going to categorize exactly what Raft is. So when I say that, Raft is a synchronous leader consensus algorithm, Raft is a synchronous leader permissioned consensus algorithm that's going to mean something to you by the end of this. And then we're going to work on implementing Raft, which is going to be a learning experience because I've never implemented Raft before. So let's talk about permissioned and permissionless first before we jump on. The majority, well, all of these kind of rely on the majority, and some of them depend on how you define majority. If it's the amount of work, or because like something like a proof of work consensus actually defines majority as the amount of work. So if you had a machine that could just do 1 trillion times more work than another machine, you could have, 100,000 of the other machine, the slow machine, and they wouldn't have a majority. It's not based off a machine, it's based off of the majority of work. So it's the majority of what. Now, that is not a Byzantine fault, and we'll get into that, because to suffer a Byzantine fault, you actually need, I believe it's 3 in. So in is the number of faulty nodes to actually suffer a Byzantine fault. So if you had 5 faulty nodes, you would need 15 actual nodes to suffer a Byzantine fault. Most consensus algorithms don't actually suffer Byzantine faults, so Raft actually doesn't suffer a Byzantine fault. But that's it's an okay assumption that it doesn't, because it's a permissioned. And let's talk about that. So we have permissionless and we have permissioned. Now, this is what you're going to see in textbooks. It's not the terminology I use, because I don't think it fits very well. So the terminology I use, which I'm going to put down here in a different color. We're going to like Venn diagram this crap here. The terminology I use is known and unknown. And we'll talk more about why I use this over permissionless and permissioned. These up here are your blockchain. This is maybe more confusing than I meant for it to be. These down here are your classic algorithms. I'm going to say classic, but classic DB Kafka algorithms. If you know a machine that is trustworthy, that's the problem. Can you know that a machine hasn't been hacked? Maybe not a good assumption, but maybe assumption we have to assume sometimes. Okay, so this is more of your classic down here, these known, and this is kind of your blockchain. Not all blockchain work on permissionless. There are private blockchains that work on permissioned, but they work quite a bit differently than the classic blockchains that you think of, your Ethereum, your Bitcoin, your whatnot. All of those work off of this permissionless. And the big premise behind these, the big premise that's the difference between these, is permissionless don't know the roster beforehand. So these have an unknown number of voting nodes before they start. They have an unknown roster before they start. I see what you're saying. These here know the entire roster beforehand. So these, and this is why I call them known and unknown. So blockchain is a good example. If you want to go and validate on the blockchain, on Bitcoin, you can go and join any one of them and be a valid validator on their blockchains. They have a unknown, they're basically open, and these are closed. That's another good way. I use open as well, and closed as another way to refer to these. So let's put some examples of these out here. So this would be Bitcoin. This would be Ethereum. Yeah, any of your blockchains. I don't know how to spell Ethereum. I probably should. Let's look that up. It's not an I. It's not an I. My bad. All right. Your Bitcoin, your Ethereum. Now, there's subtypes to this, and we'll get to the subtypes in just a second. Bitcoin only has one type. Ethereum actually changed the type that they did. We can talk about that in a second. But these are examples of permissionless, unknown, open consensus algorithms, or things that use them. These here are examples are Kafka, etcd, Kubernetes, any database, any distributed database, not SQLite, but any distributed database. I'm saying Bitcoin is only proof of work. Bitcoin is only proof of work. Cryptocurrency has a whole bunch of different ones. There's even a proof of time elapsed. I didn't actually look that one up. We can look that one up. There's a bunch of different proofs of that try to do the stuff. So we can talk more about the different types of them. These are the only two that I know the consensus algorithm off the top of my head. There's the distributed proof of stake. There's a few for cryptos, absolutely. So these are your DBs. Any distributed database uses some consensus algorithm, which etcd Kubernetes is kind of it is a database. It's a database. It's a specialized database, but so is Kafka. But these use the permission known or closed consensus algorithms versus these. So then let's talk about some of the, I would say that there's on top of this, if we're flowing this way, kind of, there's another category that spans the two of these. We're going to only talk about this a little bit, is the leader and leaderless. Yes, Ethereum is the one that's changed. Ethereum was proof of work, and now it's proof of stake in the Ethereum 2 upgrade. So Ethereum is the one that changed a bit. Bitcoin has stayed proof of work. Now, really, I think I'm going to say this. I know proof of work and proof of stake are leaderless. But I believe all open unknown one are leaderless, but that might not be true. The majority are, at least. While the permissioned ones, the majority of them are a leader because it actually makes it easier. So let's now talk about some actual consensus algorithms here. So in the Bitcoin, we've already talked about it. It's the proof of work. There's the proof of stake. There is the distributed proof of stake. And then there's the proof of time. There's a couple different proofs. It's like the time elapsed. That's not how they do it. I don't know that one as much. But it's basically everybody's given a countdown timer, and you prove that that time has elapsed. While on the other side, really famous ones would be Paxos. Raft, which is the one that we're going to be doing. I'm trying to think. There was another one that I wanted to call out. There is a synchronous one. It's the PKA. Phase King algorithm. Right? I think it's the Phase King algorithm. Don't quote me on this. Let's look it up. Nailed it. The Phase King algorithm, I think, is particularly unique because it actually is one that can actually sustain a Byzantine attack, assuming no crashes. It has been proven that if you account for crashes, it's impossible to sustain a Byzantine fault. Do I say epic or epoch? It depends. It depends. All right. So ads are starting soon, so I'm not going to continue the discussion while ads are going. So, I'm just going to kick around. Do I say enum or I say enum most of the time, but sometimes I say enum. Yeah, I say enum most of the time. I feel like I sometimes shift that one around too. I feel like when I'm talking about computers, I say epoch more than I say epic. Oh, 100% I'm an American. Everybody in chat could have told you that. My accent probably could have told you that. Yeah. So, yeah, it's like, do I say Aegis or Aegis? I actually use both. I feel like I am just a confused individual. I feel like that's what it is at this point. I don't know what I'm speaking most of the time. Sometimes words. Hopefully. What I really need is I need an ads are playing screen. I agree. I'm trying to say, I don't say the word a whole lot. I actually think I use epoch more than I use epic. I think that's one I use epoch. I don't think I use enum though. I think I use enum. Enum, I know it's an enumeration, but it's weird still, I think. I have used enum because if the person I'm talking to says enum, I immediately follow suit. Like my brain just switches over and it's like, all right, this is the language we're speaking. Now that being said, it is a GIF. Period. It's a GIF. Do not call that a GIF. That is just... anything to get back at the British. You know, I hold a grudge. I'm just joking. There's several British people that watch this show. I'm just joking. That's why I use Fahrenheit, or I mean the freedom units. There's also only one way to spell color. Yep, there's only one way to spell color, and it's a Z. That's the end of the alphabet, is a Z. Like a zebra. We don't call it a zebra. It's just weird. I know the whole rest of the world. I know the entire rest of the world. But this is American English, please. I think the one thing... Or our ads are done. But I was going to say, I think the one thing that I mispronounce, and I'll give it to the British, is probably correct, but it's aluminum. We just need to change how it's spelled. Like, that's the optimal solution. Aluminium is like, yeah, I get that it's spelled that way, but you know, pterodactyl is also spelled that way, and so is pneumonia. But we don't pronounce them that way. We spell them or pronounce them pneumonia and pterodactyl. So we can either pronounce things in a sane way, like aluminum, or we could change how they're spelled. I'm open either way. Aluminium is just not the answer. Americans took British English to show them the middle finger. All right. All in good fun. We tease here, but all in good fun. Let's get back to our train of thought here. I have no beef with anybody that speaks English different than I do. They're wrong, but they're entitled to being wrong. All right, so we have kind of these two main ways of doing consensus here that are kind of different at their core. Now, I do want to know that all of the ones here, Paxos, Raft, and the Phase King, are actually all leader and not leaderless. Now, there are leaderless and asynchronous ones. I don't know them very well. That's one place I could learn a little bit more. When I was making this, I realized that, like, in the known or closed consensus algorithms, I know that there are asynchronous leaderless algorithms. I'm just not as well versed in them. So when I go to make the videos of this in January or February, whenever I get the time to actually make the videos on this, that is one of the things that I'm going to learn a little bit, and we'll probably do a stream on leaderless ones where we investigate them a little bit. And likewise, the ones of these I know are leaderless, and I don't know if there is a leader one. So this is a little place for investigation on my part that I've learned by making this class, was like, I think that there might be leader ones, and I'm guessing the leader ones are the private blockchains, but then I'm guessing if they're the private blockchains that they actually are more of a permissioned algorithm. So a permissioned or known. Again, this is what you would find in textbook. This right here, this word. This is your textbook. It's a terrible word for it. It's a terrible word for it. People that write textbooks should talk to me first. Naming's hard. It's a known or closed and unknown or open roster. Okay. I mean, I think they get the permissionless or permissioned, where like you have to have permission, Like generally this is either a TLS cert or, some sort of certificate, cryptographic certificate that allows you to join. I get it, but I don't think that it's as easy to remember. Okay, so we have these different ones here. And the other thing that we can talk about is whether it's asynchronous or synchronous. And Paxos, Raft, and Phase King are all synchronous, which makes it a little easier to reason about, in my opinion. And these up here are asynchronous for the most part. Synchronous assumes that every round of voting, basically, a good way to think about it is every round of communication can't affect the next round. So obviously these are all talking on networks that allow them, there's some delay and whatnot. Not everything happens on every single tick. If we go back to the Raft thing, Raft consensus, and look at this that goes here, you'll notice that there'll be, I'm just going to call it a heartbeat. We'll get into the terminology of Raft in just a second. And this is one round of communication. So this is one round of communication, and this is a round of communication. Until those rounds finish, you can't have another round of communication. You can't affect anything else that's happening. So until all of those balls come back to it, that is one round. And so that's what they mean by synchronous, is basically saying that like anything that happens after that can't affect this round of communication. So these can have communication, they just can't affect their voting on this round. So that's the synchronous versus asynchronous. I do believe asynchronous, where you allow for that, is much more difficult. It's probably why it's not done. Now, that's another place I could know more, is why asynchronous. Basically, it's harder to survive a Byzantine fault. It requires more healthy nodes. So I think it's really inefficient. Paxos is already, Raft is already pretty inefficient. It's very chatty by design, and we'll get into that. All right. So these are the types of consensus. These are some of the different things. So let's talk about how these try to reach consensus. So these are kind of easy. These top ones are kind of easy to understand. Proof of work. Proof of work is basically this. We're gonna do proof of work up here. Proof of work. So proof of work says if I have 5 good nodes that are working, and let's say that each node produces 1 work, whatever this work value is. 1 work. It does 1 work. I know, it's dumb. We're just gonna do this. I don't want 6. I don't want 6. Who did that? There we go. Okay, so we have this proof of work, and these each do 1 work, and basically, via cryptographic proofs, these they refer to it as a chain, but it's a ledger, it's a log. It's just a log. These are making a log, a very long log. And basically, via cryptographic proofs, you can prove that this is the log. Now, what happens is if I want to rewrite an entry in here, if I want to rewrite an entry, this entry right here, I actually, to make it cryptographically true, I have to go through and rewrite history. I have to rewrite all of history to keep the cryptographic proof, which means to attack this network, I couldn't do it with 2. We're going to make these adversaries a horrendous color. This color. Ugh, gross. I don't even know what color that is. They wouldn't be able to do it if they also only had one work. They were able to complete one work. Because these would continue adding to the log, and the log would get longer. And basically you accept the longest log, the longest chain. And so these could never rewrite history, catch up to these nodes, and get the longer chain. So this attack would fail. So to actually successfully attack this chain, you would need 6. And now you've gained the majority here. You would be successfully able to rewrite history and get the longest chain and change what the truth is. Async is quite hard track and yeah. You know what though? You're right. And this is why we're doing Raft first. But it doesn't mean that we don't need to learn async a little bit. That's what we're going to do. Probably January, February is learn the async protocols. I do think that they make a lot of things a lot harder. Raft took the idea that they wanted to be a simple consensus. So when you think of Raft as a synchronous leader, permissioned algorithm for solving consensus, you have to assume that that's the easiest path for consensus, and provable consensus. Because that's literally in their paper. If you look up the Raft paper, I'm not trying to be like offensive or anything like that. That's not my goal. That was literally their goal, was to make the easiest consensus algorithm out there. And yes, we will get into Lamport time clocks because I think that's actually pretty cool. Now, Lamport made the Paxos. So when you're talking about, he developed Paxos, but Paxos is quite a bit harder than Raft. Faster, probably arguably faster and more efficient, but also more difficult than Raft. That's why we're trying to do Raft now. Right, and the problem with a timestamp is you can't just... there's timestamp things that you have to deal with there, so yeah. But yes, you're absolutely correct. All right, so these are the types of consensus. Let's talk about proof of stake. Proof of stake works very much the same way, except instead of effort being put up, you're actually staking some value that you've had. I'm not getting into the politics of these type of blockchains. I personally, I don't like proof of work or stake. I think they both have their issues, and they're different issues. We can talk about them, but so basically this is proving that you have a stake in the chain. How do you get a stake in the chain? Well, you have to buy it. That's it. Or you have to be the founders of the blockchain that had it and just have copious amounts of it, so you own a copious stake in it. But you're staking your... I mean, in this case, they stake tokens, but you could really stake anything in theory. And you're just saying the group with the largest stake gets to control the chain. So if this is the group with the largest stake, they get to control the chain. If this is this group with the largest stake, they get to control the chain. If there's no group that has a large stake, then in theory, no one gets to control the chain, but that's not entirely true. Yeah. I don't remember exactly. I know that there's the lamppost clock that you can... let me look this up. Let's see. It's lamppost clock. Oh, that's not how you spell Leslie Lampost's name. I probably mispronounce it. Not lamppost. My goodness, I'm an idiot. Lamport. It's Lamport. It's Lamport. Lamport clock. There we go. This is the I'm sorry. I'm sorry. I think it's Leslie Lamport. My bad. I just said lamppost. You're welcome. I destroyed your name and I didn't even mean to. There we go. At least I got some part of it. At least I got some part of it. If you want to join the stream and mock me for my last name, you're more than welcome to, and I would love to have you on the show to talk about distributed algorithms because you obviously know quite a bit more than I do. I'm actually being serious. If anybody all right, let's go on. Yeah, so those are effectively what these are doing for consensus. Now, Raft and Paxos do a little bit differently because they have a leader. So in Raft and in Raft and Paxos, what happens is that you have a leader. And really, I'm going to oversimplify it because we're going to get more into implementing Raft and these will make more sense. In theory, a lot of what happens is electing the leader. After that, everybody else that's part of the cluster, and really you keep these clusters smaller. In a distributed one like this, the goal is to have the larger, the better. In a proof of work or proof of stake, the bigger the cluster is, the more people in it, the safer it is from any one person or group taking over. You have 1 trillion, work units, and you would need 1 trillion to take it over. So the bigger the network, the better. In a closed, that's not true. These are very, very chatty. They're very, very chatty. If you look at Raft here, and we speed this up to real time, this is what your network looks like. This is real time. And the thing is, this is not even actually synchronizing data. And this was actually a leader change. You saw right there, leader is now number 4. This is just their standard communication. So if you're actually writing stuff to this, and this is disseminating that information, the leader is. Oh, my computer's lagging now. I don't know what happened there, but anyways, it doesn't matter. The whole idea is that these systems make the leader basically responsible for all updating of the ledger. So the leader is the one that does all the updating to the ledger. The only thing these guys are responsible for is electing a new leader. So if this one goes offline, has a problem, or something else, what the responsibility here is that these 3 can now reach consensus themselves. Now, you never have a 4. This is horrible. There should always be 5. And I'll show you why there should always be 5, 3, 5, or 3, 5, or 7, or 9. And this goes to majority. Is this routing algorithm? No, Monta first. Welcome, Monta. It's good to see you. Did somebody bully me? No, I mean, did my surname, or as we in America like to say, last name, cause me to get poked fun of? Not really bullied. The worst thing is if you've ever watched, there's a kid's show called Sesame Street, and there's a count that counts. When you say Merrick counts, everybody is like, haha, that's a funny thing. It's a phrase. It's not a, merit counts. So yes, I can count 1, 2, 3, 4, 5. And so then that would be the count. Not really bullied. Poke a little fun. Sure. They poked a little fun. I think poking fun is a little different than the word bullying. I wasn't bullied for my name. I was bullied for other things, but not my name. So let's talk about why you want to have an odd number here. Right, Monta, this is the one on distributed databases. You are correct. Well, we're covering the Raft algorithm. We're actually making Raft. And right now we're talking about types of consensus, and we're going to get into some code in just a second. And this is the types of consensus. You can go back and watch the video, or again in January, February, I will release on my YouTube channel a more polished one. There's a few things that we need to look into, like asynchronous algorithms. I'm not saying that we'll actually implement an asynchronous algorithm. It might be too much work. Maybe that's a thing to do next December. But yeah. It's something we need to learn a little bit more about and include in our one. So the reason you want this is simple math. I will prove today that if you made a Raft cluster with 4 nodes, it's actually less available than one with 3 nodes. Less available. Now, we talked about why we want consensus, and it's because we want to have a higher availability on a set of data that we agree on. All these machines will have the same data. If we put a piece of information in there, we want to know that if it says that it wrote that data, that it stored it in the log, that all of the machines in that have that data. So if we lose any one node, now, to reach consensus, we need a majority of the machines. Let's talk about that in a 3-node system. In a 3-node system, the majority of the machines is 2. So that means we can lose 1 node. We can lose this node, and we can still reach consensus because we have 2 nodes. If we lose 2 nodes, a second node, via network partition or let's get a better red. Is that a better red? No, that's not. Ew, gross. Ew. Better red? No, that's more pink. Oh well, we're just going with this one. This is the one we're going with. All right, whatever. If we lose 2 nodes, we can't make consensus anymore because we have to have a majority. And since it's a known roster, so this is where it breaks off from the permissionless or unknown. In one like Raft, we actually know the roster. We know how many nodes are supposed to be there, and you know a lot of information about it. So in a permissioned, again, this is what the textbook would say. This is better. It's a known roster or a closed loop. This is a better way to think about it. This is the Merrickism. Basically, it's the better way of actually referring to it. I'm proud of my humility. Dude, yeah. Amit Singh, you know what? This is the worst. I'm coding Raft in Rust. Look at this. You know how many people have joined asking if I'm doing Raft or Rust because they're not the same game? And I'm like, I don't know what to do. I don't know what to do. So in here with a 3-node cluster, we have, let's make this green. We have figured out that we can lose exactly 1 node and maintain consensus. Okay, now let's add a second node, another node. In a 4-node cluster, how many nodes can we lose? How many nodes can we lose? Scott B, it's good to see you. What's up? Does anybody know? How many nodes can we lose in a 4-node cluster and maintain consensus? Have quorum. They'll call it quorum. Don't ask me how to spell quorum. starts with a Q. And I can't draw with a mouse. Anybody know? I'm trying to make a point here that this is actually less available than a 3-node cluster. You can lose one. Thank you, Amit Sighing. You can lose one. And that means, again, to have a majority, you have to have 3 nodes because 2 is not a majority. So you can lose the exact same number of nodes as a 3-node cluster, but you have more fault points. You have an extra machine, more network, another machine to fail. So you actually have more fault points in a 4-node cluster than you have in a 3-node cluster. So I really, really strongly recommend people don't run it as a 4-node cluster or a 6-node cluster because you're actually adding more fault. Now, I'm probably being a little pedantic where it's probably not that much less safe. You know, you probably don't have that much less fault room. Like you're probably gonna hit the same P's most likely. But the thing is, you added another machine to actually only reduce your availability possibly. Like the only thing it can do is hurt you. It's not gonna help you. So when you're talking about these known or closed, or again, textbook permissioned clustering algorithms, you know the entire roster ahead of time. So you know how many you've lost. You know that the roster was 4 machines. And so they know, each node knows how many machines it needs to get quorum. And so please don't put an even number. Like that's just don't do an even number. Prime numbers are the best. Yes. Not only am I proving that odds are better than evens, I'm trying to get the point across that it's actually detrimental. Like having an even number in your roster is worse than having fewer nodes. Not only are you paying more, not only are you having more network traffic, you have more points of failure for the same number of lost machines. So if each one of these are on its own switch, you know, let's say you have some routers here, and let's delete these over here. If each one of these are on their own switch over here, so these are going to be the switches here. You know, get a nice little distribution going here. If this node fails and this switch fails, and this obviously these are all going to each other, you're out of quorum because you added more places to fail. Primes are also better in collision prevention and hashes. We haven't talked about hashes, but yes, primes are generally better in general if you can do it. Did you know? I'm going to drop a little fact bomb here on you guys that you need to know. Did you know that cicadas, maybe the most annoying bug in history, you know that they only come out on prime numbers. And did you know they come out in prime numbers for a reason? I didn't know this. But the reason they come out in prime numbers is that the chance of a collision is much lower. So you have some that are 7 years, and you have some other prime ones that are I think it's is it 17? Something like 17. So you have like 2 different cicadas. And the problem is, if these cicadas have no defense of their own, and so basically everything eats them, everything's their predator. And so their only defense is to come out in massive amounts of numbers. And the problem is if these two mix, if these two mate, they will have some that come out at 3 years, some that come out in 5 years, and some that come out in 7 and 17. And the problem is they won't come out in mass. And this is actually bad and actually decimates the population of cicadas. So they actually leverage that there's less collisions in prime numbers, because if they were like 2 and 4 years, they would be coming out at the same time all the time. Whereas they only come out at the same time like once every 200 or 300 years at this point, which is pretty cool. Anyways, it's a applicable thing to software. There you go. I said fact bomb, but I mean, it is a fact bomb, but I mean, I don't know if you guys wanted to know that. Anyways, when doing consensus, when you're doing closed consensus, it's best to always run a prime number. Now, some people will go crazy on this, and some people will run Raft, or etcd is a prime example of Raft, and they will do this. They'll be like, oh, okay, more's better. I have seen Kubernetes clusters like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, this is not. This is my recommendation. That is not what I wanted to do. That was rough. I just wanted to spread you guys out like that. Oh gosh. Nope, we're just leaving them. This is my max etcd cluster. And the reason is etcd is chatty. You add more than 9 and you'll actually be able to support a smaller Kubernetes cluster, because these machines will burn down. They will literally catch on fire, burn your data center down if you go up to 11. And the amount of that you got wasn't great. So just don't do it. I mean, like, and if you do, I mean, I would actually say don't go over 7, whatever 7 is. That's 7. Don't go over 7. It doesn't actually buy you that much more reliability. I mean, if you have really faulty machines, get new machines. Get new machines. If you have really faulty machines, just get new machines. Because it doesn't buy you that much. If you have stable machines. Oh, you're from Scott B. You're from Alabama? I did not know that. Do you actually live in Alabama now? Man, I'm from Kentucky, so not very far from Alabama. My goodness, cicadas are annoying. My goodness, are cicadas annoying. But I did find it really interesting, the math behind why they come out. Primes don't overlap. This is also why guessing primes for like cryptography is like all of this all overlaps, which is also really cool. Like all of these things. So like for hashes, for cryptography, for all of them, all overlap on the same principle for cicadas, for freaking cicadas. Upstate New York. Upstate New York is beautiful. Upstate New York is beautiful. Upstate New York is very pretty. All right, so we made this file yesterday. So let's jump into, let's get some code going. You know, I mean, unless if anybody has anything more they want to talk about this, I get a little passionate about not making huge clusters because it's the worst. There was somebody that wanted to run. I want to say it was like 23 control plane nodes for Kubernetes. And I was like, well, you can do that as long as you put etcd outside of that. And they're like, no, we wanted etcd to be 20. And I was like, no, you don't. No, you don't. You do not want 23 etcd nodes, period. talked them down to 11, and 11 was still a pain. 11 was hard to maintain and get a very large Kubernetes cluster, because not only is Raft chatty, Kubernetes, if you think about it, anytime that you update anything in Kubernetes, which includes the status of an item. So if you have items that are changing status and logging that, think any operator, that includes more heft onto your Raft in the backend. And the more these things chat, the bigger these beefier the nodes they have to be. My goodness, Kubernetes already keeps a lot of information in etcd. It can get painful. I usually only get excited about things that that have hurt me, that have hurt me in the past. That's when I get really excited about things. All right, let's see. So last time we did this gRPC, we kind of need to break this up a little, because what we need to do is actually start the Raft gRPC server. And what we need to do is we actually need to update this. If you look in our main, we actually start our database, which we kind of don't want to do anymore. We kind of don't want to do right now because we just want to do Raft. I think what we're going to do is we're just going to comment this out. Which means this is us creating the database, so like database won't start anymore. So I think that's the answer here. We're just gonna comment this out for right now. Let's just put a friendly comment. Start and serve HTTP server. Will we have to Tokyo main this crap? Probably. Will Actix Web main do the same thing? I don't know. I feel like this is going to be just fine but we're gonna just do Tokyo main for right now. Uncomment to run database. Database API. So actually, no, let's not do this. Because yeah, let's not do this. Let's just see if we can't I made a boo-boo. I'm not gonna retype all this. Let's do this. There we go. We still want to parse the args. Yeah. We should do a to-do or fix me. Agreed. Start server. I just want to make it all about I want to make it all about Raft for right now. I realize that we're doing part of why we're doing Raft is so that our database can run on different nodes. But right now we're just worried about doing the Rafty parts, and then we can do, you know, the actual, this is just, everything we've done so far is how to put and find data on disk. That's it. And so this is going to allow us to just worry about that. I think that this should be fine. Although honestly, maybe, I don't know. Anyways, I think this is the right way to go. Let's actually add some stuff that we need to our config now, because now we need to actually parse a roster. So let's do this. Let's do a good old clap, short and long. And then let's do not gRPC, roster. Should we just parse it in as a string? I think that's probably the sanest thing to do. Are we just going to do a comma delimitated string? Or do we want to do this as a config file and just pass in a config file and make it where we have to pass it in as a config file? I feel like I just want to keep it in the command line because that will keep it simple for when we're testing. Is roster a config? Yes. Every node has to be known at start, right? So when the process starts up, it has to agree on a roster with all the other nodes, or else it won't start. In Raft, at least. So here, this has a 5-node roster, and each of these nodes had to know each other at the start. I could, and I was thinking about it, but to be honest, and I know this is kind of lazy, this keeps it so that I can just pass everything in the command line. So like we have this compose. So this actually tests for us because it will spin up 3 nodes. And now I can just pass in roster in here with the roster of here. Instead of like making a config file for each one of these. It's probably more of a config file thing. Probably. And maybe once we're done testing as much, we can do that. I think right now, just keeping it as a string that will parse out, just a comma delimitated string. Maybe it's bad. It's probably bad. I always regret my decisions later. Almost always. Let nodes equal seems pretty good. Now this is expecting enum result. Oh, okay. This is one thing that I don't like about enums. This is one thing, or not enums, but procedural macros in Rust. Is this right here, this Actix web, is complaining because I don't return a result, and it's expecting a result at this point. So like I could just return okay here, and and I thought that would fix it, but it didn't. Oh, wait. Now it's saying mismatch types, anyhow error, and STD error IO. I have similar names, but are actually distinct types. Where am I breaking that? I am not breaking that. Good old Rust. Wait. Is this an anyhow result? I didn't bring in anyhow, did I? I mean, I have any. Oh, it's anyhow is okay. I bet that. There we go. Why did that get brought in? I don't know. I don't generally bring in anyhow. I do use anyhow, but I use anyhow like this. So that it's very explicit because I don't like it overriding the things. All right. Okay. Cool. That did fix it. Whew. Sanity has returned. Sanity has returned. I don't know how that got imported. I assumed I did this, and then I hit return on this. And see, this is saying use anyhow. It's actually going to import it for me. Ugh. I did it without thinking. Okay. So we're back. So we have our nodes. We're going to split the roster by comma delayed. Yep. And now we can start we need to start up our server. And then we can do like a ping. I think what I want to do is very first, just to make sure that communication is flowing between all of these nodes. I think what we're going to do is just set up a ping. Modprog made it? Manyhow. No, I haven't. But if somebody in the community made something, I'm more inclined to use it. If there was one thing that I would love from Rust to adopt from Zig, it would be that macros are just Rust. It would be that macros are just Rust. That would be the one thing that I love about Zig, is that macros are just Zig. It's pretty cool. It's pretty cool. But I will have to look into this. I have not used it. But I do know that Modprog joins stream every once in a while, so next time he's on, I'm gonna have to tell him that he needs to promote his crap more. I actually like Swift. Amit Singh, I would. I actually like Swift. Modprog did a stream with Togglebit. Do you have a link to that stream? If you do, please post it. I can go look and see if I can't find it. But that would be a really cool stream. Actually, I was going to make it like a leader flag and just set this as the leader. But what we're just going to do is every node is going to ping every other node once a second. That'll be fine. We can see the logs. I'll message Togglebit and see if if he doesn't know. And I'll look for it on Togglebit's stream. I'll just look for his VODs. That would be a cool one. I'll post it in the Discord if I find it. Those guys are much better at Rust than I am. Are you doing it using gRPC? Yes. Yes. We had this conversation yesterday that if I was doing this for real and not for educational purposes, I would probably use a messaging protocol or like 0MQ or something like that. And the reason is that there's overhead. Standards are this is what I was learning. Standards are easy, but they have a lot of overhead. Even gRPC doesn't hold a match to something like 0MQ or an actual messaging standard, but it's a standard. It runs over networks. But if you're in data center, which we've already talked, we are a permissioned, known, closed loop to be run in a data center. We don't have to worry about running on the web. We don't need this standard, and we can compress the crap out of this and get much more efficient. So if I was doing this for a real database, I would have my own wire. I would either have my own wire protocol or I would use something like 0MQ. You know, a lot of databases do their own wire protocol, ones that actually care about performance, that is. But for this, we're here to learn. We're not here to, you know, if you guys want to learn to make your own wire protocol, if that's what we want to do, we'll do that at some point. But right now, we're trying to learn Raft and consensus, and so wire protocol hasn't really. So anyways, gRPC makes it simple. And the reason gRPC makes it simple is because we can just define the stuff that we want here and generate the code for us. It's actually literally simpler than JSON. And I think maybe not, but pretty close, pretty close. It's pretty dang simple. You would make it very difficult to argue that it's less simple. You can have retries with queues. I will ask you a question, Monta, and we can answer this later. Do you want retries with consensus? Do you want something out there doing that, or do you want to know that it failed? Is that failure acceptable? Maybe. I don't know. How many failures do you want to have on your your network in your data center? Hopefully not that many. Across the internet, sure. You have to be much, and this is again why you're solving the problem. These standards exist to give you a lot of those things. Hopefully your data center network doesn't have a whole bunch of failures internally. That would be appalling. Even my home network doesn't have those failures. Normal RPC versus gRPC? If you're asking what the difference is, I mean, there's not much of a difference. It's just gRPC is a whole stack. So gRPC is a stack. gRPC has a bunch of different things. Let's see. It's a RPC protocol. It leverages an RPC protocol. It leverages protobufers for the messaging. Protobufs for the messaging. It leverages, it has its own server, own service server, it uses HTTP2, so we can put, it's over HTTP2. So this is, it's an entire stack, whereas RPC or regular RPC is just the protocol. It's just this piece. gRPC has nothing different. It's just using the remote procedural call style. This is really RPC versus REST. This is just a complete stack. It gives you an opinionated stack. That would be saying like REST versus Swagger. They're both the same thing. REST is just the protocol, the way the style, versus the actual stack that you're using. That was not a great example. That was a terrible example. I'm sorry. That was a bad example. I accept that. Okay. I think what we want to do is almost the same as here, how we create this database. We kind of want a thing that is responsible for our Raft stuff, I think. We did this gRPC, but this is not the solution. This literally just what is this? Well, this is kind of our solution because this has all the messages and how it serves it. Okay, so yeah, let's just do it here. So again, I'm using gRPC with Tonic because it's easy. It provides us that easy layer. This isn't about how to write your own message protocol, wire format, to be the best database ever. If you guys want to use NullDB in production, please don't. Please don't. Please don't. Okay, so basically we want to reply anytime we get a ping request. And then we also want to have a server that's sitting there sending a ping request. So we get a ping request and we're going to reply. But now we also need a loop that is every second sending out a thing. So we still need to, yeah, do something that has logic. That has logic around this. Do we want to do it in this thing or... I love the quick protocol. HTTP 3's quick protocol is super cool. You have a couple problems with it though. You have a couple problems with... Oh, ads are in progress. So I'll stop for just a second because ads are in progress. Oh, Monta, I'm happy for you. I don't want that to sound bad. I feel like that could sound that could be misconstrued there. I don't mean for it to be. I'm glad you don't get ads. I have to look and see if I can. I don't think I can turn them off. I think I can be like, I don't want to do mid-roll ads, and then they'll just do it randomly. I mean, I think this is the best way because it allows me to control it for when the ads actually play. And I can just, you know, wait some. Oh, drawing this over this was not the best. I would probably use this if I was just going to pick something to leverage. I would probably just pick 0MQ. I really do like 0MQ. If I was going to, again, this wouldn't be nearly as simple. It doesn't generate the code. We'd have to type the code. There would be stuff to do. There would be things to do. gRPC again still makes this really simple, and that's why we're using gRPC. I know that we've had this conversation several times. We're using gRPC because it's just simple. It's simple. But if people really would like to develop our own or leverage something like Quick and just test it, the problem with Quick, and what I was going to say, Amit Sai or Amit Singh? I don't know. The problem with Quick is there's one problem. Not all routers, switches support it. So there's a problem with data centers actually supporting Quick at this point. Yeah, I mean, I'm not getting jeffed. You guys are getting jeffed. You're getting jeffed, not me. I actually don't see any ads. I get this little warning that ads are playing. That's it. So, you're getting jeffed. You know, I would like to think that the amount I got off those ads, I don't know. I think that I made like 50 cents 1 month where the ads were really good. So, you know, I'm rolling in it. As long as I make it pennies and save up several months, I could probably at least roll over it fairly easy. Probably not in it, because that would require a lot of pennies, and I don't know that that's enough pennies. This is where, like, me personally, I feel like Twitch should accept this. Twitch should accept this. Anybody with less than 50 concurrent viewers, ads don't pay off. And you should let them just disable it completely. Just disable it completely. It doesn't make me any money. And you guys would have a better viewing experience. Now, maybe that would discourage people from giving me like a Prime subscription or, you know, some other subscription that does make them money. Maybe that's what their thinking is. Like, there has to be that reward. I don't know. Anyways, let's get back to it. I'm completely okay with doing a quick base thing eventually. I am trying to write okay, this does not make sense. Monta, you confuse me. You said contradictory things. You said lightweight, and in the same sentence, you said C++. It's like using a sledgehammer to pound a nail in. Just teasing you. I'm just teasing you. What are you're not able to understand the indexes, the segmentation of indexes. What type of index are you trying to make? That's a good point to start with. What type of index? There's a bunch of different types. Are you doing a sparse index? Are you doing a fat index? It's not called a fat index. I always called it a fat index. It's not a fat index. It's the opposite of a sparse index. Are you doing like a bitmap index? What type of index are we talking about? Spanking a baby with an... What the crap can... It's a dense index. That's what it's not. It's not a fat index. It's a dense index. Scott B, I don't know what chat you thought you were in. What? Oh, the sledgehammer with a nail. I see. It was in reference to that. Never mind. I got it. So you're doing a dense inverted index. Is that what I'm assuming? Now, is your index distributed? So it's not distributed. That's good, because that makes everything so much worse. So I haven't gone through reverse indexes or inverted indexes. So I don't have a video on that yet. We could do that next after Raft if you'd like. There's also the... I call it a tree. I don't know. I didn't go to school. I'm too dumb. The tree you could look at doing. I don't know exactly what you're wanting to... You're saying a search. The try is another good way to search. All right, so I want to here do impl raft server raft, so that I again can make a struct raft. So this trait is the only time I use this, and now I can make a struct raft that is like my raft server. Okay, I always called it tree, but like it seemed dumb to call it a tree as well. Because there's a lot of tree algorithms. There's a lot of tree things, and it's not really like I feel like it needs a better name. I know naming's hard, but I feel like it needs a better name. It's used a lot for suggestions. Yep. Yeah, it's like autocomplete before ChatGPT. Right? ChatGPT is just a better tree. Try. I still hate the name. I hate the name. Change my mind. Change my mind that there's not a better name for it than tree. I realize written down, it's easy enough to understand that it's different, but spoken, it's worse. Rust is the only language that you can read and don't understand a single line? Oh, I'm sorry. I'm sorry. See, for me, that's Perl. That's Perl. Have you ever looked at Perl? I feel like you haven't read Perl yet. Yeah. Perl and Lisp. Lisp is another good one. Please go look at those and tell me that they're more readable than Rust. Please go try to fix one of those. Yeah. I feel like Rust isn't that bad, but oh, nice. All right, what are we gonna do here? We're gonna have a Raft server impl. Not a public. We're gonna have a. Ooh, actually, this is a good question. I actually think it's right. I was going to do it as a Raft server impl, but this is actually a Raft server, the thing that we wrap it in. Do we even need a reference to this? I want to say no, but we're going to do it anyways. We're going to do that. Then we're going to have a Raft client. Oh gosh, what happened there? Raft client. Realm client. What the garbage? I wanted Raft client. All right, this is what I wanted. I haven't done a lot with array languages. I have touched array languages. I understand the premise. I'm not good at them. I wouldn't do very well. If people are really interested in me doing, I'll do a stream of using one. I'm happy to do a stream or two randomly. I'm not going to leverage them for anything because I don't know them very well, but I feel like, and this could be wrong, because obviously I say this not using them a ton. I feel like array, I feel like these languages are really fantastic scripting languages, and maybe not in the more complex. Like, oh, okay, and I'll say this for like, and obviously you can write big, large, complex things with a large team in Haskell, but I find pure functional to be kind of in the same way. Whereas like some of their beauty and their simplicity is really fantastic for like a fantastic script, but then expanding a team to support all of them and everything becomes much more difficult. Again, could be a skill issue, but sometimes you have to hire individuals based off of a skill issue. I mean, you can't expect every engineer to be as good as me. Hopefully they're better, but you know, you have to be able to hire the people. So like at some point, a skill issue is a problem too. So like if you wanted to go do it in Haskell and it's capable of being done in Haskell, doesn't mean that you can go hire a team and do it in Haskell. If it's too hard and it's just as easy to do it in Go, well, it's easier to hire a team to do it in Go. I'll try some crazy languages at some point. Absolutely, if you guys like. Happy to do it. It would be fun. Anyone can write in Go, and that's the beauty of it. Anyone can write in Go, and that is the beauty of it. Like, and I don't mean that in like a bad way or anything. Like, that is a beauty of Go. I can hire a team of people that haven't even written Go and get them writing Go very quickly and efficiently. It's beautiful in that regard. I obviously have my I like Rust better than Go. I think it's a better language. It is a little harder to get engineers to write in Rust though. What did ChatGPT just give me? What did ChatGPT just give me? I accepted it. I think Rust makes more sense. I 100% do. I do think the learning curve's a little steeper. So this is what I actually think the learning curve of these two languages are. This is Go. Let's actually just do some axes here. These are the axes. And this is Rust. This is Rust. Rust is really hard at the start. It has some weird things, and if you're a good engineer, you dive right into those weird things like, you know, ownership and borrowing, and then they're threading and then pinning memory. Like, who the crap knows how to pin memory, and why do you even want to pin memory? I've never had to do it in any other language like C++. But it has a very steep. But then as soon as you get those basics down, Rust becomes really easy. Learning the harder thing in other languages is really easy. Go is kind of weird in that I think that Go, learning it, you can become really competent in Go. And then there's this drastic increase right here, where doing some simple things in Rust become incredibly difficult in Go. Become incredibly difficult. You want something to guarantee something runs on a single thread, you just can't do it. You have to call out to a C function. You want to, you want to do a actually multi-threaded thing where you control the thread. You can't do it. You can't do it. And it becomes incredibly difficult to do. You want to do the simple multi-threaded green thread web server. It's really simple. You'll sit here and you'll never touch these things. You'll sit here and never touch this if you just make a microservice. You'll never get to this, and you can just be flying, just flying. The other thing is you're going to plant a bunch of foot guns here. You're going to plant a bunch of foot guns because there's a bunch of things you probably don't realize you shouldn't do and that you're doing that's causing you to copy and causing you to do a bunch of stuff like that Go doesn't stop you from doing. So these are my my graphs on skill. I use green threads all the time. What are async await? Green threads on Tokyo. That's what they are. 100%. Right? You're just slicing up work. You're not actually getting... Now, Tokyo has an executor with real threads on it, but it could just be one thread. Like, it could just be one thread. So, I use green threads all the time. I also use real threads as well, like system threads. Oh, have I implemented them? No, I haven't implemented. If you guys would like to learn to implement an executor for fun, that's something we can do next year as well. This year we got to do Raft. This year we got to get this done. We're probably not going to get this done this week, but I'll stream some next week as well, and we'll finish the simple Raft up. All right, what the garbage did we get here? All right, so we got a new function, which is... Why did it do parse unwrap? This doesn't even make sense. My goodness, maybe toString would be fine, but my goodness, that was weird. Sometimes ChatGPT just does weird things. Implementing green threads in C might attract more people. Do you just like to see me suffer? You want me to do green threads in C? You good person. Why is it using IPv6? I actually had the same question here, and the reason is the examples. I almost guarantee you, I'll show you why. I'll show you why. Oh, I was in the right place. I had the same question as you did, and then I went like here, and I was like, oh, let me see what you do. And 100% ChatGPT is just, oh, they do parse unwrap. Oh, interesting. So this 100% just copied it from here. They do parse unwrap too, which means they're I bet you they're importing something that's parse. Why did it say I need an explicit? Am I not using address? Oh, I'm not. Oh no, I am right here. I can attempt to write something in C. I've never actually written a ton of C. Never written a ton of C. What plugin am I using? Yes, I'm using a plugin. Let me think. Oh, I don't know why I did that. This. I'll put this in chat. I have a little bit of configuration. I don't remember where I put that. I need to clean this up at some point. So Control J for Copilot. I actually need to remember that is to accept. You can also use tab as long as the other prompt isn't up, which is what's gotten me in trouble a couple of times. I just got this, so I'm not quite... I need to remember Control J for accept. Oh, this is a Raft client. Oh, this is the weird part. I thought it was going to start the Raft server. Okay. You know what we want? We don't even want this. There's also a Kodi one. I want to give it a try too. There's Kodi. I just did that one because it was simple. There's also a Kodi plugin that I want to play around with. All right, so instead of this, we actually have, okay. We actually have a function, start Raft gRPC server. Oh, but it doesn't give us, it doesn't return a type. You know what we're gonna do? Let's do this. Okay, Control J. Yeah. Control J does it even if it's up there. And then we can hear. Okay, wait. I need to get better about this. I want to select everything inside of this. So it's CI open. There we go. Server. Done. Sorry, I'm not very good at Vim. Not very good at Vim at all. What was I doing? Oh, now what we're going to do is also return this server. I don't know if this is a good idea, bad idea. We aren't failing on anything, so we're just going to return a Raft server of type oh, and this has to be, actually we can do explicit type here, right? Because we actually want it to be a Raft server impl. There's only going to be one. There can only be one. Oh, we do move it here, so maybe we just return the server. Ew, I don't like this. I don't like, you know what? Do we need to refer to this at all? I feel like the answer is no. I feel like what we do is, I have done a gross thing here. We remove this altogether. And we rethink life decisions that we made up here when we did this. To me, I feel like we should have a reference to it. That's going to let us shut it down and things like, we do need to have a reference to it. But what I think we should do then is do this. This is, what does this give us? What type of builder? What type of thing? Server. Yeah. Okay, so it gives us a server. So we're going to have this return server. So how do you sync nodes? Do you check log database and reconstruct for last or what? I'm not sure I understand what you're asking, Monta. I'm not sure that I understand what you're asking. Oh, we're implementing Raft. That's the consensus algorithm that we're going to use. So effectively, we're going to make the nodes reach consensus if you're in strong consensus consistency mode. This is why we talked about cap a little bit. So there's a lot of ways to deal with this. A lot of databases let you deal with it in different ways. There's, relaxed, or some people will say eventual consistency, which is a pretty bad consistency, but it can have its uses. What if we make this not serve? I don't know what to do here. I don't like this. Doesn't give me a reference to it, so like I can't actually do anything. There is a heartbeat. So in Raft, there's a heartbeat. So if you're looking at this, maybe it broke. There we go. There is a heartbeat. And actually in Raft, this heartbeat has to be recorded in the database itself, in the log. If you're talking about like etcd. It's why this heartbeat can be hard. It has in standard Raft, it has 100 milliseconds to reply, and it has to take your response, write it, and send back in that amount of time. I'm just like, you know what? Right now, I have a ping and a vote, but these aren't fully flushed out. I'm just kind of getting stuff together. The echo is just to see that it responds. Don't read too much into it at this point. I'm working on dumb stuff like, how do I return this server? And maybe I don't even want to do this anymore because this feels dumb. This returns nothing. Do I even just... I almost feel like the answer is to... let's see. Is to actually just build this here. Let's see. What am I doing? Oh, those errors were transient. I mean, the nodes will vote. That's part of the Raft protocol. Let me update my titles. Technically, we're a little different. Yes. So all the nodes at the very start will basically vote for a leader, and hopefully maybe tomorrow we'll start to actually do the vote. The votes are actually fairly simple. Basically, one just says, "Hey, pick me," and it's kind of like the first one to get all the votes wins. It's a little more complicated than that, but it's not too bad. You use Mint? What do you use Mint for? Do you do a lot of computer graphics? I use Nalgebra. Instead of Mint, I use Nalgebra. When I'm doing, like, if I do stuff with linear algebra, I use Nalgebra. Oh, you... Oh. Oh, okay, for your distro. Sorry, you said you use Mint. I was doing Rust. I was like, I don't know. I think Scott's memeing. Nobody uses Mint as a distro. I agree with you. Scott B, don't meme on us that hard. We can't take it. Let's see, what do I use? What do I use? I use Arch. I forgot for a little bit. I couldn't remember. You know, they all are the same. They don't have any differences. Linux is Linux, you know. So fun thing, Scott B, I used to work at SUSE. Which is a German company, which is pronounced SUSE, like Porsche. I learned this the hard way. I thought it was SUSE. Other people in the US call it Suzy. It's SUSE. I used to work at SUSE. Which distro are you looking at? Tumbleweed? By the way, I always called Tumbleweed Troubleweed. So... Oh, Troubleweed. You're on the Troubleweed. I'm telling you. One does not merely install Troubleweed. It's addictive. It's addictive, that Troubleweed is. This is about to get entirely not cool. I wouldn't use it. It's not the one I would use. SUSE had a crisis of who they were, who they wanted to be. And this is eventually what led me to leave. And there's a lot of people there that are fantastic people that support the fantastic open source system and that are absolutely awesome. They had a crisis of identity, and there for a little while they wanted to be the Red Hat, which they wanted to be this enterprisey Red Hat. And that's like when they went through buying up a bunch of littler projects like Rancher and whatnot. They're not bad. Let me do this. I do not want to discourage you from using Tumbleweed. There's some really good people that work on it that are really brilliant, much smarter than I am. And they have some really cool things, like MicroOS and MicroLeap are actually kind of cool if you're looking for a really small platform for like running containers. These are really cool concepts that I absolutely love. So try Tumbleweed out. Try it. Give Tumbleweed a try. If that's what you were thinking, just do it. Just do it. Don't let me discourage you. Just do it. Give it a try. Let me know how you like it or don't like it. Let me know. Tumbleweed is kind of like Arch. And you know what? The best thing, you're going to get something that no other distribution has. And like, I will be the first to admit problems in my own stuff. And I also like to be the first to talk about things that they did really well. I think one thing that you're going to love, I loved it. Zypper, their package management. Quite possibly my favorite package manager out of everything. I love Zypper. Absolutely love Zypper. If you want to talk about something they've done right, the command line tool to manage packages on your distro is probably the best one that I've ever used. Yay doesn't even hold a candle to it, and Pac-Man for sure doesn't hold Pac-Man is garbage. Let me be clear. I think Pac-Man is terrible. Yay is usable. Apt is fine. Apt and Yay are fine. Like, they do the bare minimums. Use Zypper for a little bit. Like, it's even like in the details of like, hey, you can get colored output and like really easy to read charts of what's installed, what repos are installed. It's really intuitive. It's really easy to update your machine. It's just fantastic. It's just fantastic. That's what I'm saying, Monta. You know what? Like, I can like something and admit that it has problems, just like Rust. I can like Rust and admit that there's things that I wish were different. Like, how you make a macro shouldn't feel like witchcraft, but it does. It does. It feels like witchcraft and it can suck. I don't like implicit returns. I much rather explicit returns. Just let me type the word return. Pac-Man just is the worst in some regards. In some regards, it's the worst. You know, I'm not talking about how like it uses Git and allows you to install things from Git. I think that's really innovative and nice. But there's aspects of Pac-Man that is just the worst. Just the worst. The command line tool zipper is fantastic. I absolutely love the command line tool zipper to manage packages on an open source SUSE machine. It's really nice. It's just how it does everything is fairly nice. You can have it do the output for like machine readable and human readable, which outputs it differently. Like it's well thought out. It's well thought out. Do we have a vec of, so the roster, and this is a vec. This is a vec of strings, right? Zipper does allow you to get any RPMs. So like if you have a RPM repository, it allows you to get any of those. I didn't try it from other distros, so I don't know about that. But I know like if you want to connect it to a Red Hat registry, you can. It's fine with any RPM registry. That's all I ever tried. Maybe I didn't work on the Zipper team, so I don't know Zipper that well. I mean, I used it quite a bit, but I don't know it well as in like everything it's capable of doing. I used it to install Go. Come on, that's all I needed it for. Install Go, Vim, Visual Studio Code. That's all I did. And it was glorious for that. It was glorious. So we want to do for node in roster. Node. This is Control J for node in roster. Oh man, this did pretty well. Let Raft client equals the Raft client for the node. Await unwrap. Done. And then insert that node into our Raft clients. Wait. Where's Raft clients coming from? We need to get rid of this. And what we need is a Raft clients. Oh, thank you, ChatGPT. I know it's Copilot, but Copilot is powered by ChatGPT, so. I know. I'm thinking the wrong thing. I feel like I should just do the thanks Obama. Thanks Obama. When it gets it right. Which would be like counter the meme. Let's just do clone. Let's be lazy. Done. Laziness wins. Okay, we'll do shorthand. I don't like shorthand as much, but you know, whatever. Okay. Does this work? So the thing we did here is you'll have multiple clients because you'll have multiple servers, so you connect to all of them. This is maybe where gRPC isn't as nice because you actually do connect. You actually make that connection, but it's nice. It's fine. How's everybody's weekend going so far? Are most people off next week? Are most people off? Oh, a little bit of news about tomorrow. Unfortunately, I am off work, but I have some work that I'm gonna have to do at like 3:30 my time. So like I have about 3 hours of work. It's about 3 my time now. So tomorrow I'm gonna have to get off a little bit early because of that. Either I'll stream later that night or I'll start a little bit earlier. Unfortunately. But I have off the rest of the week, and we're doing a bunch of stuff. We'll be streaming every single day from noon Eastern time to, whenever. Probably dinner-ish time, because I like dinner. Dinner's good. Also, starting Tuesday, I have some books to give away. I literally have some books to give away for people who want to learn. So if you're wanting to learn, I'd like you to only sign up for the giveaways if you could leverage these things and don't have access to them, because it's going to be books like Designing Data Intensive Applications. Fantastic book. If you haven't read it, you need to read it. For the newer people, if there are any newer peoples, maybe my channel doesn't get a whole bunch of newer people, but I have Grokking Algorithms, which is a really good book to just start to understand algorithms. And then I have one of these, Introduction to Algorithms. This book is like 14,000 pages, but it's like a must read for just about any engineer. Now, I didn't go to school, but I did teach myself, and I taught myself via books like these. So I wanted to help you all. And so if any of you guys could use these books, I will be giving them away, and we'll have a little bit of giveaways. So that'll be starting Tuesday or Wednesday. I forget which day it starts, but Tuesday or Wednesday. Absolutely some of the best books ever created. All right. So we have multiple clients. Let's see. What is this doing? Oh, okay. So like in this, it needs to have a ping request. So we'll just do, you know what? The Raft server probably needs to know its own ID. So we'll do this node ID. Oh my gosh, I hate this keyboard. I can't wait till I get a new keyboard. I hit F1 because it's smashed right together with escape. Absolutely the most frustrating thing. Now, we don't have a Raft client because we have to send this to everybody. So we'll just do a for node in, not client, in self dot Raft clients. Values, that's what we need. We need values. This is perfect. And we're just going to print the response. And what I want in the response is for them to send back their node ID. That's the response to a ping. And we'll make that. And so when a ping gets sent out to everybody, right now we're just going to respond with don't need to clone it. Let's see. Oh, this is, we don't need this. We're just going to return okay. All right, I want to delete everything in here, so I'm just going to VD, nope. That is not what I wanted to do at all. Not quite what I wanted to do, but it worked. Oh, I said that I wanted a ping reply. I'm not going to return anything from this. Nope. Not happening. Maybe eventually, but not now. This should be created for each one, or oh, it doesn't support clone. Request doesn't support clone. Okay. In that case, we're going to have to do this. Ads starting soon. Can we do this? This is not what I want. This is not what I want. All right. No. What's up? Yeah, the both boys have been down here sleeping. All right, ads are almost done. Oh no, have I not been showing my screen? Nobody said anything. Nobody said anything. All right, let's see. We want not this. Can we do this? Nope. What am I doing wrong? Yeah, okay. I got it. I got it. What is this? That's okay. Okay. What am I doing wrong here? I'm doing something wrong. It's a Raft client. I got it. I got it. Type. Oh, do I need to do something like this? There we go. One second. One second. I thought this was like this, but do I need to I have a mutable reference to self. Okay. What did I screw up here? I feel like it's this. Cannot borrow node as mutable as it is behind a reference. Right. I understand that this iterator yields an at reference. I get that. I am missing something stupid. No, we want to dereference it. But when we dereference it, it gets this. Missing field message in slash. Missing structure fields message. I don't get that. These diagnostics look... Oh, this is down here. It jumped down for some reason. Okay, never mind. I was like, oh, that doesn't even make sense. Saying different words. It was saying different words. Type tonic, response, ping reply cannot be dereferenced. So at this point, it makes me feel like it's trying to dereference this. Okay. Right, this ping returns this ping reply. Oh, I'm an idiot. I'm an idiot. I forgot. I forgot. That was my bad. Okay. That's better. We just gonna copy and paste this here. We're going to delete this. We're going to, for the time being, this actually should probably do something with something, but it doesn't matter. We're going to make a vote request, but this request is going to be inside here. This is going to be a vote request, done. Oh, we shouldn't do ping. This should be vote. Yeah. There we go. Done. Okay. So the other thing that we need to do is we basically need to just do a run command here. Pub. You know, I'm going to accept this. I don't know what it is, but it looks cool. What's this? Request vote. I don't quite get what they're doing here. Actually, let's do this. Let's change this to vote. We're going to do vote response. Ping response. Dun 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 dun. All right, what we are going to do now is, send to heartbeat is something we have to do, but we're not going to do that right now. We're going to do pub async fn run. It made stuff. I think this is where we're going to start the server. Start Raft gRPC server. There's nothing to be, actually, we're going to want to wait on this on a different thread. We're going to want to use the Tokyo because this should block. I think. So what is that? That is Tokyo. Do I not have Tokyo installed? Do we not have Tokyo installed? What? We haven't. We have Tokyo installed, right? Oh, we don't. We don't have Tokyo. Oh, that's because everything's been Actic Web. That's my bad. Definitely should have Tokyo. So let's this is actually weird because Actic Web uses Tokyo. You know what, Eagle 11? This isn't Rust. This is cargo. If you want to see beauty, look at this. Well, that's commented code. Look at this beauty. I don't know how you could look at this and say it's any less beautiful than... I mean, like, if you want to talk about ugly languages, we'll talk about Perl. Talk about Perl. We'll talk about... Oh, you want to know ugly languages, which I know you have experience with? Let's talk about Objective-C, which is objectively horrifying. Let's talk about Objective-C. Let's talk about Objective-C is a high-level general purpose. oh, Wikipedia, you make such jokes. Let's talk about bad and rough to look at. Oh. How are you doing, Eagle 11? How are you doing? Also, don't judge Rust based off of my code. Don't judge Objective-C or don't judge Rust based off of my code. Especially this. I'm doing something that probably shouldn't be doing. Probably shouldn't be doing. This is, oh, you know what? This is still on me. This is where we do want to do this for the time being. We'll have to fix this. We'll have to fix this. We're gonna Tokyo main it up. You were doing pretty great until you looked at my code. Fair. That's fair. That's fair. This is the opposite of production ready code. You know, everybody has to write some opposite of production ready code, and I do not know why my IntelliSense is not. Working for me. A wait at the end of a line is unusual. Yeah, it is. It is, except in Rust, and then it's very usual. So the idea is an async function doesn't do anything unless if it's awaited. And so async functions actually return futures, not this. This function actually returns a future of result, of a type of result. So when you look at, let's see, when you look at this means that this ping function is actually an async function, which means it returns a future. So this returns a future, and so then we have to await it. Awaiting it says, hey, no, we actually want to, you know, await on the return value. So we could wait on the return value or whatnot. Until you call await, no work has actually been done. So it's kind of standard. And the question mark just means that if this fails, so this await actually returns a result, we unwrap the result, and if it fails, we return early. We don't go to the second step. This would just be like typing, you know, if error. You know, if it would be the same as doing this right here, return error, except that, you know, this isn't Go. And so we can do this very simply just by putting a question mark. It's very clean, very clean. Once you learn Rust, you just don't want to do anything else because it's just so clean and beautiful. Tar83, thanks for the follow, dude. So Tar, we have a problem, Tar, and you know, it's partially your guys' fault. We have a problem. One second, quick cone of silence. I'll show you the problem. Everything, all my Twitch alerts are powered by AI run from my home network. And right now, I have this problem where this switch is offline. This switch right here is offline. And this switch is the thing that powers my Twitch alerts. And because this switch is offline, it's your fault. Not your fault, Tar, but the rest of chat's fault. My Twitch events don't work. So I gotta work on that tonight. I would stream some of that, but I don't really know what's wrong. Kind of like I don't know what's wrong with this code. Eagle11, thanks for the follow. Tell you what, when the next time you guys are watching and Twitch alerts are working, just unfollow and follow again, and you will get an automated message. It's really fantastic. It's generated by AI. We wrote a lot of code to do, you know, to handle all the Twitch stuff. We did that live on stream here. We'll do some more to work on it. It's pretty fun. Right now it is powered by ChatGPT. Eventually we want to run our own AI model to do it. It makes up some pretty crazy stuff. Eagle11, thanks for the follow. It's pretty fun. It's pretty fun. Now, I don't know why I can't. What I was wanting to do was Tokyo run async. I want to just run an async block, spawn. That's what I want to do, spawn. But it's under Tokyo. Let's... There we go. Yeah, just Tokyo spawn. Why isn't it working? I just want to do this. But it's not working. I don't know. Okay, well, anyways, I'm going to just do it, and I'm going to make it okay with it. That's what it's going to happen. I'm wondering if my language server is having a problem. Because look at it now. No, that's ChatGPT that's giving me that. Let's try actually just getting out of Vim. Anyways, sorry Tar83. Sorry that you missed your thing. Again, hopefully we get that sorted out tonight. Hopefully. I don't know why my Switch is having problems like this. But we'll get that, and then I highly recommend you unfollow and then follow again directly after so you don't miss anything. Okay, so this week we've been learning about consensus, and so in that, for any of you that are just joining, we're learning about consensus, and to do that, we're actually implementing the Raft consensus algorithm. It was an algorithm designed to be easy to understand. We're learning about topics about consensus, and we're actually implementing Raft. That's what we're doing now. I have never implemented Raft, so this is going to be it's already being a little bit of a pain in the in the derriere. But that's okay. We'll do it. So this seems to be fine now. Let's... Okay. It was just the language server. I should have restarted the... There is a key combo in NeoVim to restart the language server. I obviously don't know it. Since most use the question to unwrap nulls safely. Oh, gross. No. This is not unwrapping nulls safely. It's unwrapping the results. So it is unwrapping Eagle 11, but not unwrapping nulls. There's no such thing as nulls in this. That's why this is the null labs, because we've eliminated the use of nulls. Think about that. That didn't even make any sense. Sorry about that. Sorry about myself. Okay, so we've done that. We've spawned that. And then the other thing we want to spawn is basically a loop that's going to ping once a second. Let's see. Let's just accept what... Oh, look at this. It's close. It's close. Yeah, we want to ping all the other servers once a second. And then we're just going to see the logs. So let's see. We can do a... And our ping function actually already pings all of them. So this actually goes through all of the ledger. Or not the ledger, but the roster. So that's good. So we don't need to do anything there. What we do need to do is basically just make this a... let's see. No, we don't want that. No, I said for, but I meant loop. We literally just want to loop indefinitely. Wait. Borrowed data escapes outside. Wait, where did borrowed data escape? We can't have borrowed data escaping. That's not really acceptable. Oh. Let's see. What do we want to do here for this? I hate Rust async. I shoot myself in the foot more times than not. Really, this loop just wants the clients, right? Which are just these. What is a Raft client, though? It is clonable. Interesting. I'm wondering if we need to actually put this in an arc. I feel like that would be the lazy thing, and we don't actually need that. That feels like the lazy thing. What if we made ping just take the clients and we just passed that in? So we then could clone it. I feel like that's a better thing here. So we just make this, like this should make this fail because it wants the mutable ones. But what we should do is pass in a mutable reference of hatch maps. What this is going to be clients, and that's going to be a hash map of this thing up here. Not at all what I meant to do. That didn't work out at all. You know, I had plans for that, to select that with like one key combo, and my plan said no. My plan said no, thank you. They said no, thank you. So then we can just do clients here. Done. Mismatch types. How are you mismatch types? Oh. Right, it's not going to be able to borrow clients as mutable. Can we do this? I'm not sure why it's complaining about this. Oh, because I'm an idiot. I'm an idiot. Were you guys telling me? Nope. You guys weren't telling me, but it's part of the type, not the name. I had sometimes I thoroughly impress myself. Yeah. You know how it is sometimes. Actually, now that I'm at this, let's go back up here. Ping shouldn't be part of this. It doesn't need anything of self. So we'll just remove this. And we're going to remove this. Let's see. And we'll just slap that down here. That didn't work. Didn't work at all. Okay, this is looking better now. I don't know if what I'm doing is good or not, but it's looking better in my opinion. Okay, so now self doesn't have ping. We don't have to call ping. What we will do is just call ping, and ping requires self dot clients, Raft clients dot clone dot await. Yeah. Okay, yep, we need a mutable one. That's fine. But that's still gonna have borrowed data escapes. Okay, but what we can do is let mute Raft clients equal that. And then we pass that in here as Raft clients. Right? Done. We fixed the problem. Why is it upset? We don't want, okay, let's underscore equal there. Are you happy? You're happy. We're happy. We're all happy now. Okay. Now we don't want to just do this. We need to sleep. Oh, beautiful. Beautiful. Thank you, ChatGPT. Okay. Does everything work now? Now we just need to call run? Okay, so we get our nodes. And now we just need to... Yeah. Really, probably what we should do is this. Let's just do this. I don't know if this is exactly what we want to do. Boom. We want to do that. We want to jump over here. And then we just want to do args.id. Done. New takes a node ID and a roster. Okay, this is fine. We'll just change this to reference of strings. String slices, I mean. This should be fine. Oh, this is garbage. Who made this? Oh my gosh, what a travesty. What a travesty. Not at all what I meant to do. Gross. Gross. We want to undo all of this. Okay, not the node ID part. The node ID was part. Good change. Good change mixed with bad changes. Let's see. We want to fix this as well. All right. So, you know what we'll do? What we'll do? I've got this under control, right? So here we actually loop through these. So this is we'll take these in as this, and then we'll convert them here to make them work. To string. Look at that. Now we're working. Now we're working. Uh-oh. Uh-oh, we gotta do it twice. We gotta do it twice. We gotta do it twice. Now, okay, there's a lot of upsetness. There's a lot of upsetness here, but it's not too bad. We just need to call toString. Right, right. Yes. Yes. Okay. That was more work than it needed to be. More work than it needed to be, but we are now cooking on all cylinders, as they like to say. As they like to say. We are now cooking on all cylinders. Who's ready to see this run? Who's ready to see this run? Anybody? Nobody has to. Nobody has to. We can keep it a secret how well it works. Now the idea is that each server will start up and ping the other ones. That's the idea. But let's actually update these to have roster equals. Let's do this. Roster equals. Oh, we haven't actually seen that these talk to each other. I don't know that these actually talk to each other. Because I don't know what their IP address is or what port they bind to. How do we define that in this? We need to define that. We'll do 3000, 3001. I know the first one will be 3000. So 3001, 3002. And then ID. Wait, what did we call it? It wasn't ID. Was it? It wasn't ID. No, it was ID. It was ID. Stop making me doubt it. Okay, so ID equals 3000. So this one will be 3001, and it will be 3000. This will be the roster. And this will be 3002, and this will be 3000. And space in between here. All right, let's look that up. Docker compose. Just ports. Okay. We'll do this. We'll do this. But then we need to update the code because somebody made a mistake. So we'll just do this. And this will be 3001 to 3001. And then we'll do the same here. And this will be 3002 to 3002. What we need to do is, I know that we're kind of using ID improperly. I get it. But what we need to kind of do is basically use that ID when it binds to the Raft server as the port. Wait, where do we start the server? Oh, maybe it didn't run. Yeah. So in here, we need to, this needs to be updated to take, a string called port. It's going to be a string. And this is going to be like this. Boom, boom. And this is going to be format. This. Port. Close. Freaking hit F1. All right. And so that's looks golden. Now we just need to jump to the error that I'm sure is complaining. Don't take me to these. I only want real errors. And then self.node ID. Our node ID is our port that we're running on right now. Yeah, it's really terrible. It's a terrible system. I get it. Dot clone. Okay. We'll do it the right way. Let port. Yes, exactly what I wanted. And then this just becomes port. Thank you. Yes. Okay. Now we're ready. Are we ready? Are we actually ready to see if all of this code that we've written works? I think all we have to do is get a cup of coffee. What time is it? Oh, yes. Oh, yes. It is time for another cup of coffee, a leg stretch. So if you guys want to see if all of this work has paid off, you're going to have to wait. You're going to have to wait for some coffee. That's right. Enjoy the music. Sit back, relax a little. I'll be right back. All right. All right. Let's see this go. Let's see this go. Let's see. This is... Right? That's all we have to do? I screwed it up. This has to be a list. There we go. There we go. We're going. This is going to work first time. Really what we should see is them all chat about the same time, since there's no delay in spinning up the different ones. All right. That's building the containers. This takes a little bit of time. Oh no, and an ad's starting just as we're about to work for the first time. It's gonna work the first time too. Wait. Oh yeah, it's still building. It's still building. While that's working, actually, really quickly, cone of silence. We're gonna quickly jump over and look at my network. This is the weirdest thing. This. I screwed something up. Let me look at the Unify app here while we're yeah, we're still building, which is weird. Seems a little too long, right? I guess we did bring in Tokyo. Did we validate that it actually builds? Did we? Because I don't know that we did. Maybe we should have done that. Because this seems... Let's see, what is it saying? It's garbage. Garbage. Okay, I'm gonna give it a little bit of time while I'm resetting my switch. Switch resetting time. All right. Switch was reset. Now, can we adopt? We'll see. Okay, and this doesn't seem to be doing anything. So let's actually stop that and just run cargo build ourselves. Does it do? Does it build? It does. There is no problem. I don't know. Like, obviously, this is doing a clean build, so it should take longer. Russell, is the news happening? Yes, it should happen. So a friend invited me over, and I'd like to go. So I think I'm gonna have to do the news tomorrow. Because I need to go over to their house to eat. My kids haven't seen their kids for a little while, and I was gonna do it, and then I ran out of time, and the people hadn't joined yet. Or you specifically, you're the one person that joins to watch my news. So I don't have the time now, but I did have things that happened this last week that I think it would be good to talk about. So I don't want to miss that. So maybe I can start. Are you working tomorrow? Are you working tomorrow? Maybe I could do it at like 11 a.m. tomorrow. But that's not great for you then. When would work well for you? Because I was thinking about once I was done coming back home and doing the news, but then it would be late. So I'll tell you what, Russell, I will do the news either tonight, but I'll stop the stream and it will be later tonight, and I'll just go through the news and you can catch up. But that way the VOD will be marked very well as the null news. I try to make sure that VOD stands out. And then it's either that or it will be tomorrow. Either before we do the consensus or after we do the consensus. Stuff. So yeah, I'm really sorry about that. I was planning on just doing it like right about now. But then but I was invited over to somebody's house for dinner that we haven't seen for a while. And my kids know that his kids as well, so sorry about that. I will do the news this week though, because there was definitely a lot of stuff. Did you know that V0 released, or Vercel released V0? They still haven't replied to me about their pricing fiasco. I didn't expect them to release it. I didn't expect them to. This is failing to build for some reason, and I'm not sure I have enough time to actually figure it out. Cargo build works here. Let's actually do Docker build. Let's just build the Docker here. Oh, that doesn't look good. That does not look good. I want to stop that. What the garbage? A file system loop found. Uh-oh. I have done something bad. File system loop found. Okay. Did we really screw up the Docker container that badly? What have we done? The only thing I could think of is like a, you know, in this, it wouldn't follow a symlink in the copy though. Like that's all I could think of here was a symlink. What have we done? All we did was write some Rust. I'm gonna stop it and see like exactly what it dies on. Here we go. Here we go. We should be close to the top. Okay, this is better. libc. Okay. This is interesting. It's one of the cargo things. Interesting. I'm wondering if this is because of the Tokyo, because the only thing we did new was the Tokyo import. And this has a file system loop. Basically a circular dependency in the file system. Well, this is horrifying. This is horrifying. This is a terrible container. This is all that it is, though. Oh gosh, it's the simplest container ever. Oh. How did we mess this up? We could even get rid of this. I mean, like, that would be fine. But I mean, we're just dying on this. Why are we using this feels weird. Like, why is X11 part of the container? X11 shouldn't be, right? Right? Do we have something else weird in the cargo file? Like we have clap, Actix web, cert. So all of these were in there originally. The only new ones are Prost, Tonic, and Tokyo, right? Why would these cause this? Let's do cargo tree. Let's look at what Tokyo is bringing in. This is probably Tokyo. Let's see. Actix web. Actix router. So, oh, you know what? Does Actix use Tokyo? I'm wondering, right here. I imported Tokyo and Actix Web uses Tokyo too. This is probably our problem, which also uses libc. And then I had the audacity to also use Tokyo. But this is 126, same version, right? I think we're on... Here's our build dependencies. Don't care about those. Yeah, I think we're on to something here. I've never had to deal with this problem before. So we're going to have to deal with it solidly another time. I do have to get going. It is time for me to go hang out with a friend of mine, for my kids to go hang out with his kids. And this is a good tomorrow problem. This is a fantastic tomorrow problem. Thank you, everyone, for joining. We will do the news either tonight or tomorrow. I'm sorry that it's not happening at the right time. I know I generally try to do it at the right time. Sorry about that. And I will see you guys tomorrow or tonight, but probably tomorrow. See you guys later.